Hey kids, we're starting a new unit. Welcome to Objective 16 Notes. This is Dr. Rones here to give you a little clarification from home. Disclaimer before we start, this isn't going to be the best lesson in the whole entire world. These are the high points from our lesson. And this is meant to be a little help for you from home, maybe a refresher, perhaps get you going on your homework. And of course, at the end, I'll share some contact information. So if you have further questions, I'm always happy to assist if I can. So, let's start this lesson with what we have learned previously in our last unit. We learned that this means 5 squared, or 5 to the second power. And it does not mean 5 times 2, it means 5 times itself, 2 times. 5 times 5 is 25. Or 5 cubed does not mean 5 times 3, it means 5 times itself, 3 times. 5 times 5 times 5 is 125. Now, we haven't talked about 5 to the 4th power, but if we follow the pattern, that just means we're going to multiply 5 by itself 4 times. Now, moving backwards is a little bit trickier. If I have 5 to the 1st power, that just means I just have one group of 5. So just 5. And then we have 5 to the power of 0. Oftentimes students will say 0, but it's not 0. It's 1. What? Now watch. As I move up the line here, I'm increasing by powers of 5. 5 times 5 is 25. 25 times 5 is 125. 125 times 5, which makes sense because I'm increasing the number of times 5 is being multiplied by itself by 1 each time. Well, what times 5 is 5? 1. Yeah. Truly, any number to the power of 0 is 1. Anything to the power of 0 is 1. And also, any number to the power of 1 is itself. So for example, 5 to the power of 1 is going to be 5. 10 to the power of 1 is going to be 10, and so forth. This is kind of the anatomy of this expression here. So 7 to the 4th, of course, like what we said, means 7 times 7 times 7 times 7. This is called the base number, the big number. And this is called the exponent. And it's important that the exponent is raised up and a little bit smaller. And it tells how many times the number is being multiplied with itself. So 1, 2, 3, 4, and that's why there is a 4 there. So using those simple rules, we can write various expressions using exponents. So I understand that 4 times 4 times 4 is 64, but if I wanted to write that using exponents, here's my base of 4. It's being multiplied with itself 3 times. Now we can do the same thing with variables. This variable of x is being repeated 5 times in multiplication, and so it's as simple as that. Now sometimes your base is going to have funny things like parentheses and negatives, and as long as it's the same thing all the way across, then you use that whole expression as your base. 1, 2, 3, 4, 5, 6 times like so. Your base can also be a whole expression, but this whole expression is repeated exactly 3 times, so we can say k plus 2 cubed. Now, at some point you're going to get a mix of variables. You should work left to right, one variable at a time. So our first variable here is x. It's used twice. Then our next variable here is y. It's used 3 times. Please do not use a multiplication dot in between. It's implied when the two go together, so no multiplication dot. Sometimes too, you will have numbers mixed in. Those always come first. So there's our 5. There's only one of them. Because the instructions say to use exponents, I'll use an exponent. We wouldn't normally do that. That's kind of silly. But we're following rules here. 1, 2, 3, 4. And a single b. So again, I'll use that 1 exponent. Yeah, I use that exponent of 1 because the instructions say to. Now, knowing about exponents helps us with word problems. This one is a good example because as generations go on, there's exponential growth in population here. It says 1 generation ago, your 2 parents were born. 2 generations ago, your 4 grandparents were born. How many grandparents were born 3 generations ago? It would be 1, 2, 3, 4, 5, 6, 7, 8. Well, what if you don't want to draw all of that out? Every generation doubles, and if it occurs 3 times, 2 to the 3rd power is 8. This represents 2 to the 3rd, that's the 3rd generation. 2 to the 2nd, that's the 4th generation. 2 to the 1st, that's the 1st generation. And here's u, 2 to the 0, which is 1 single u. Kind of cool. Now you can use that to calculate 10 generations ago. 10 generations ago, that's not 20. That's not 2 times 10. That's 1,024. 2 times itself, 10 times. Fascinating, isn't it? Okay, so let's apply this in some ways. We did a fun thing in class. We found our exponent name. We're not going to do that right now because that's kind of just a fun in-class thing. And I want to use my teacher notes actually to help make this point in the next section. I think it would just be easier to show it. Okay. We are talking about the subtle differences when we have different combinations of numbers and signs and parentheses. So especially in these 3 here, you can see that for each of these, I have a set of parentheses, a negative, and the same numbers each time. But the order does matter. So for example, if the x1 is on the outside, that means that base, the whole thing is being repeated. But if it's on the inside, if it's only on the 2, it just means that the 2 is repeated. And that doesn't include the negative. The negative just goes out front. Or here, the exponent is on this part here, so only that is being repeated 4 times, again with just the negative out front. And here, the exponent is just on the 2, so it's being repeated. So another clarification is the only time the negative or the sign is being repeated is when it's within parentheses, like this. And once you've written it in the expanded form, that helps you make sense of your solution. So here a negative is being multiplied with itself 4 times, so that gives us a positive 16. But for each of the others, we're multiplying that 2 over and over again with a negative out front, so that's why these are negative. Here is another example of the same thing. All of these are negative like the ones above except for this one, which makes sense because now I have an odd exponent. So negative times a negative is a positive, negative times a negative is a positive, and then I'm left with this one negative. So that's why this is negative and this one is positive. So these subtle differences are something that we learn when we get a lot of practice. And so I put these all here for you to have a reference as you're working through your homework. I do encourage you to write the expanded form when you are working so you can make sense of your solution. Okay, let's talk about substituting values in for expressions. And so I'm going to, thank you, give myself a little bit more space. So I want to find the value of each of these expressions after I have subbed in these values for their corresponding variable. So for example, if I have x to the z power, that means instead I have 3 to the power of 4. Or that would mean 3 times 3 times 3 times 3, which we know is 81. Here we have y is negative 2. And now instead of x, I have 3. Okay, so that means, now because that parentheses has the negative on the inside, that means negative 2 is being multiplied 3 times. And so a negative times a negative times a negative is a negative. 2 times 2 times 2 is 8. There you go. Now feel free as I keep going to push pause, see what you can do independently, and then hit play. That forces your brain to think on its own, and then you can see how accurate you were. You may not be able to do it perfectly on your own, but see what you can do, partially. Y squared would be negative 2 instead of y squared. And again, because the negative is on the inside, that means negative 2 times negative 2. A negative times a negative is a positive. 2 times 2 is 4. Now here, I could sub in 3 for x to the power of 0. But do I need to? No, anything to the power of 0 is 1. So we could have skipped that. But we subbed in. That's fine. Okay, now this is getting a little bit more complicated. Y squared, when I sub in negative 2 squared, times z squared, so 4 squared. So this means, I'm going to just write it over here, negative 2 times negative 2, which is negative 2 times negative 2 is positive 4. And this is 4 times 4. Ooh, that got tiny. And 4 times 4 is 16. So really, all of this just means 4 times 16, which is 64. So I recommend that after you sub in, if you have different terms or chunks, that you do them a piece at a time. So x squared means 3 squared plus y squared means negative 2 squared plus z squared would be 4 squared. What is 3 squared? 9. Negative 2 squared is 4. 4 squared is 16. See how I did it in its own piece? Okay. 16 and 4 is 20, plus 9 is 29. Great job. Okay. 4z squared is confusing for students because sometimes they'll put the number in for the variable. So they'll say 4 and then 4 squared, 44 squared, and that's not the case. This means 4 times z squared. They're mushed together. That implies multiplication. So it means 4 times whatever 4 squared is. Well, 4 squared is 16, and 4 times 16 is 64. Again, we got it again. All right. Here's another one. This is where order of operations is important. Let's sub in our number here. We have 3 times z plus 1 squared. Oops, and z is 4. Can I do, let me use a darker marker because I can't erase that. Sorry. Okay, let's do what's within the parentheses first. 4 and 1 are 5. Okay, now what do I do first? Do I multiply first or do I do exponents first? Yes, of course I do exponents first. So 5 squared is 25. This means 3 times 25, which is 75. Okay. All right. I recommend, again, that you keep this as a reference as you're working through your homework because some of this is tough stuff and you just need to practice. You'll get really good at it once you have managed to get through your homework. So speaking of homework, let's look at that. And so your homework mirrors exactly what we did in class in pieces. And so this top section says to write each expression using exponents. That's the same thing that we did in our note. Write each expression using exponents. Be careful if there's just a single number. Make sure you still use its exponent. Okay. I think the other ones should be very straightforward if you refer to your notes. This one says to simplify each expression. So again, I'll refer you to the chart that we talked about here to see the subtle differences. I recommend that you write it all out. So this means negative 2 cubed, or negative 2 times itself 3 times. A negative times a negative times a negative is a negative. 2 times 2 times 2 is 8. So that's your final answer. This is what you must have in the box. I'd recommend that you do that. And then here, to evaluate each expression when you substitute in, that's like the last section of our notes. If you would like to work down here, you sure can do that. So this would mean, instead of y, I'm going to use negative 3. Negative 3 to the power of z. So squared. So we tell what that is. Evaluate means to solve, to simplify all the way down. So this means -3 times -3. Negative times a negative is a positive. 3 times 3 is 9. Again, this is why I said that you can show your work at the bottom. Now, I want to caution you, please do not just use a calculator for this. Oftentimes, students do that as kind of a, I don't know, fallback if they're confused on things. If you're confused on things, please come see me, talk to me, rewatch the video, show all of your steps. Do it step by step and try not to do it all at once. Do not rely on your calculator, because oftentimes your calculator will give you an incorrect answer because it doesn't have a brain like you. Okay. If you need help, I am always happy to help. Even if you just do a few of them and you're not super confident that you've gone the right way with it, take a picture, send it to me, and just say, Dr. Rones, did I start it right? And I'll say yes or no, and this is what you can do. It's not a bother to me. Happy to help. Of course, I'm also happy to help in class too. So thanks for watching, and I will see you again soon. Bye.